Okay, students, so for the next exercise of chapter 6, lines and angles, we should know about this type of figure. Okay, so let us discuss here. What you can see here, there are two lines, L and M, and both the lines are intersected by a single line N. Remember, one single line N can intersect both the lines at two different points. Okay, at two different points. So this single line N, which intersect both the lines, we call it as transversal. We call it as transversal. Okay, so what is transversal? It is a line or line segment which intersect two different lines at two different points. Okay, clear? Now the point of intersection, suppose AB. Now we can see clearly at point A and at point B, total 4 angles are formed. Total 4 angles are formed. These 4 angles, okay, these 4 angles, you see, we can divide in different types. How can you divide in different types? Some of the angles are there which are in between the two lines, below L, above M. What are those angles? They are 3, 4, 5, 6. Okay, angle 3, angle 4, angle 5, angle 6. These are the angles which are in between the two lines. These angles are called as interior angles. They are called as interior angles. Okay, which are the interior angles? Interior angles are angle 3, angle 4, angle 5, angle 6. They are why interior? Because they are in between the two lines. Okay, now outside the lines, above L, below M, some angles are formed. What are those angles? They are angle 1, 2 and 6, 8. Angle 1, 2, 6 and, oh sorry, this is not 6, it is 7, sorry. Angle 1, 2 and 7 and 8, sorry. Angle 1, 2, 7 and 8. These angles are formed outside the line, so they are called as exterior angles. Okay, exterior angles. Next, if I see the transversal, then on your right side, on your left side of the transversal. Okay, so this is the right hand side, this is the right hand side, this is the left hand side. So on the right hand side of transversal, what are the angles? I want to write angles on the right side of transversal. Angles on right hand side of transversal. Okay, what are those angles which are on the right side of transversal? They are 1, 4, 5, 8. Okay, they are 1, 4, 5, 8. And angles on the left side of transversal, on LHS of transversal, what are those angles? They are 2, 3, 6, 7. 2, 3, 6, 7. Okay, so now from the figure, first of all, you can divide the angles in this way. Interior, exterior, which are between the lines, interior, which is outside the lines, exterior. On the left side of transversal, on the right side of transversal. That means 1, 4, 5, 8, they are on same side of transversal. Similarly, 2, 3, 6, 7, they are on same side of transversal. Okay, clear? Now suppose you want to choose a pair of angle. I want to choose this angle. Let us take one pair of angle. Say suppose I take a pair of angle 3 and 5. 3 and 5. I take a pair of angle 3 and 5. Okay, in the figure you see 3 and 5. So what we can see about 3 and 5? About 3 and 5 I can see this one. These are the things that both are interior. Both are interior. They are in the list of interior angles. 3 and 5. Okay, clear? Next I can see that 3 is on left side of transversal, 5 is on right side of transversal. Yes, 5 is on right side of transversal, 3 is on left side of transversal. That means they are on different sides of transversal. They are on different sides of transversal. Okay, they are on different sides of transversal. Okay, see. Next, what is the vertex of 3 and vertex of 5? Vertex of 3 is A, vertex of 5 is B. That means they have different vertices. They have different vertices. Or you can say that they are not adjacent. Okay, clear? So what we can say about 3 and 5, both are interior. Yes, because you see they are in the list of interior angles. One is on the right side of transversal, one is on the left side of transversal. So they are on different side of transversal and they have different vertices. Can I find out one more such angles, one more pair of such angles? Yes, I can find out angle 4 and angle 6. Angle 4 and angle 6. I can find out these also. See in the figure 4 and 6. 4 and 6 is also like that. They are on the same opposite side of transversal. Opposite side of transversal. Both are interior, but vertex different. So, what is the name of this pair of angle which form this, which satisfy these three conditions? They are called as alternate. Alternate. Why alternate? Because they are on opposite side. Interior. Alternate interior angles. Alternate interior angles. Now in the diagram it is very easy to find out the alternate interior angles. See, if I draw angle 3 and angle 5, yes, in this figure you see this part, angle 3 and angle 5, then it is angle 3, it is angle 5, okay, 3 and 5. From the figure if I take the 3 and 5, if from the figure if I take 4 and 6, okay, angle 4 and angle 6, it is like that. That means they form like a Z type of structure or opposite reverse Z type of structure. Okay, or they can form this type of structure if I take Z like that, or they can form this type of structure. Okay, so whenever you zigzag structure you get it, that means you can come to know that it is alternate interior angle. Okay, next one, let us take another pair of angle. Another pair. Okay, in this pair suppose I take angle 1 and angle 5. I take angle 1 and angle 5. I take this. What I have seen in angle 1 and angle 5. First of all, angle 1 is in the list of exterior, angle 5 is in the list of interior. That means out of these two angles I can see one interior and one exterior. I can see this, one interior, one exterior. Next, I can see that 1 and 5 both are on the right side of transversal. On same side of transversal. On same side of transversal. I can see this also. And I can see one thing, that vertex of angle 1 is A, vertex of angle 5 is B. Different vertices. Their vertex are different, or you can say different vertices. These three things I can observe in these two angles, angle 1 and angle 5. Can I find some other angles of that type? Yes, I can find out some other angles also, like angle 4 and angle 8. Okay, angle 4 and angle 8, they also satisfy that condition, 4 and 8. Okay, 4 is interior, 8 is exterior. They are on the same side of transversal with different vertex. Okay, I can see 2 and 6 also form like that. 2 and 6. 2 and 6. Exterior, interior, same side of transversal, different vertex. Angle 3 and angle 7. Angle 3 and angle 7. They are also like this one. Now, what is the name of this pair of angle, like 1 and 5, 4 and 8, 2 and 6, which satisfy these conditions? They are called as corresponding angle. Corresponding angles. Okay. Now, one important thing is there in corresponding angles, that out of the two angles, one is exterior, one is interior. Now, what happen you see, suppose there are two lines, the figure is supposed like that, observe this. Suppose there are two lines are there. Okay, so line LM is like this, suppose this time. This is the transversal. But the transversal is such that when it is a line segment, transversal is a line segment. That means the transversal does not go beyond the line LM, does not go here or here. Okay, does not go outside the lines. As it does not go outside the lines, so no exterior angle will form in that case. Okay, if it goes outside, then an outside angle is formed. So in that case, no exterior angle is formed. So in this type of diagram, you cannot find out corresponding angle. Why you cannot find out corresponding angle? Because to form corresponding angle, one angle must be exterior. So you see in the figure, the line is there, transversal is there. Suppose the transversal does not go beyond the line, above the line, below the line, outside the line. That means there is no question of forming corresponding angle. Corresponding angle only form if it goes like this one or if it goes like that. Very important thing is this one. Okay. Next, after that we see one more pair of angle. Okay, one more pair of angle, that is angle 4 and angle 5. Okay, see the diagram. Angle 4 and angle 5. These two angles. What you can see about them? Number one, they are interior. Both are interior. That I think all of you can see clearly. Both are interior. Okay. Number two, they are on same side of transversal. 4 and 5 you see they are on the right side of transversal. So second thing you can observe, on same side, either left hand side or right hand side, either above or below, whatever, on same side of transversal, on same side of transversal. And this time also, for angle 4 vertex A, for angle 5 vertex B, vertex different vertex. Plural form of vertex is vertices. Okay, so what is the name of this pair of angle? One such pair is also there, 3 and 6. As both are interior and on same side of transversal, they are called co-interior angles. Co-interior angles. Okay, clear? So these three types of angles form when two lines are intersected by a single line, and the single line is transversal. Apart from these three types of angle, corresponding, alternate interior, co-interior, you can have vertically opposite. That is already there. I already discussed in the previous video. 2 and 4 vertically opposite, because these two lines intersect at point A. 1 and 3 vertically opposite. 6 and 8 vertically opposite. 7 and 5 vertically opposite. 1 and 4 linear pair. 3 and 4 linear pair. 2 and 3 linear pair. Similarly here 6 and 5 linear pair. 5 and 8 linear pair. These are already there. And 3 more types of angles we have got. Okay, now here is this one. We have not said about L and M. If L and M, they are parallel. Okay, suppose L and M, they are parallel. Okay, that means the two lines which is intersected by transversal, those two lines suppose parallel. If line L parallel to line M, if that, then you get some results regarding our corresponding angle, regarding our alternate interior angle, regarding our co-interior angle. What are the results you get? Number one result is corresponding angles are equal. Number two result, alternate interior angles are equal. Number three, co-interior angles. Already I discussed about these three types of angles, co-interior angles. are supplementary. Supplementary means their sum is 180 degree. They are not equal, but their sum is 180 degree. Only when these two lines are parallel, not always. If these lines are not parallel, then not always. Secondly, conversely, you can say this also. If one of these condition is satisfied, as I told you that there are two pairs of co-interior angles. Out of the two pairs of co-interior angles, if you can prove that one pair of co-interior angles supplementary, then line will be parallel. There are two pairs of alternate interior angle, 3, 5 and 4, 6. If one of the pair, say 3 and 5 equal or 4 and 6 equal, then the lines are parallel. There are four pairs of corresponding angle, 1 and 5, 4 and 8, 2 and 6, 3 and 7. Out of these four pairs, if in any one of the pair you can prove that the two angles are equal, then L parallel to M. Okay, if one of the condition is satisfied, then L parallel M, or if L parallel M, then all these four conditions are satisfied. So whenever in your question something is mentioned regarding parallel lines, you try to find out that transversal. Then you find out that if transversal can go beyond the line, then exterior angle is also formed. Otherwise, no exterior angle, so no question of corresponding angle. Then you see alternate interior, co-interior angles, etc. And you can find it out. If you can find out, if you can mark the alternate interior angle, if you can mark the corresponding angle, if you can mark the co-interior angles, now your problem will be related to that only. Okay, so very easily you can solve the problem. So what we should know, how to mark the angles and what is the definition of corresponding angle, which is called as co-interior angle, what is the meaning of alternate interior angle, etc. Now, here one thing you see, if they are parallel, okay, then you have got some results clear now. See now, let me consider some geometrical figure. What will happen in these cases? Let me consider some geometrical figure. What will happen in these cases? Okay, so suppose I have, say this one. Okay, I have AB and CD parallel. I have AB and CD parallel. Okay, AB parallel CD. Okay, AB and parallel, AB CD parallel, but they are like that. AB parallel CD. Okay, or they are like this one. CD. In this all figure, AB parallel CD. So I can use the results if there is a transversal. But suppose it is like that. Like that one. Okay. Okay, like that. This figure. So what is the problem in this figure you see? What is the problem? I'm going to next figures also. What is the problem in this figure? Problem in this figure is that, okay, problem in this figure is that we have parallel lines, okay, but we do not have transversal. On a single line intersecting both of them. A single line intersecting both of them. EF can intersect AB only. EG can intersect CD only. Okay, they cannot intersect both of them. They can intersect one of them. EF can intersect only AB, EG can intersect only CD. Okay, so suppose the same thing is here also. Same thing is here also. Like this. Okay, EB can intersect only AB, EC can intersect only CD. Parallel line is there, transversal is not there. Okay, parallel line is there, transversal is not there. Suppose this is also like this. Parallel line is there, transversal is not there. This type of figure is there, suppose. Then what you have to do, as there is no transversal, so you cannot use the result. If lines are parallel, intersected by a transversal, then the results can be used. But here you cannot use the result. So what you have seen, that in this figure you see, EF and EG intersect AB and CD separately, but they cannot intersect both of them together. Here also the same thing. Okay, here also the same thing. So through this common point of the two line segment, we'll draw a line, okay, parallel to AB and CD. We draw a line parallel to AB and CD. We draw a line parallel to AB and CD. Always you draw like that. Suppose I name the line as, say, PQ, PQ, PQ. Okay. Why I have drawn it? Now see, our figure is now divided. This figure is divided like this one. AB, parallel to AB we have drawn PQ. Okay, throw point E, throw point E. Then CD, parallel to CD we have drawn PQ, throw point E. Now if you see AB and PQ parallel, we have single line intersecting both of them, and transversal is here. Then PQ and CD parallel, we have same common line intersecting both of them, so transversal is here. Now we can use the result. Okay, same thing here also. When you draw this one, then I have AB and parallel to AB, I have drawn PQ, throw point E, throw point E. So I have this type of figure. AB parallel PE, BE is transversal, or CD parallel PQ, throw point E, CE is transversal. Okay, transversal. So here also, if I see this one, then AB and PQ, if I consider AB and PQ, then AE will be transversal, CD and PQ, CE will be transversal. That means if we have parallel lines, but no transversal is there, means not a single line intersecting both of them is there, then if there are two different line segments intersecting both of them, through their common point, you always draw a line parallel to our given lines. Okay, and after that you get two different figures having pair of parallel lines and transversal. Okay, so in maximum question it is done. So if you know this type of things, then the second exercise of chapter 6, lines and angles, the second exercise will be easy if you know these things. Okay, when your teacher will explain the sum, if you already know this one, if you can remember, and by drawing the figure, okay, you practice it like that, you draw figures. Okay, if you draw the figures, and in the figure, okay, after drawing the figure, you mark, say suppose you draw a pair of parallel lines, a transversal, you mark the corresponding angle, you mark the alternate interior angle, you mark the co-interior angles. Okay, then vertically opposite, or linear pair, etc., etc. When an angle is bisected by a ray, what happened? These three things you practice beforehand, then this chapter will be very, very easy for you. Okay, all of you, bye bye. Next, again, we'll come with some other videos. Okay, hope you like this video, hope it will help you. Okay, if it helps, then you please like, subscribe and share the channel. Thank you.